You guys ready to rock and roll here today? Yeah. Okay, so tell me what you guys know about triangles, just off the top of your head right now. What's one thing you know, Dave?
There's 3 sides.
3 sides, okay, the obvious 3 sides. What else do you know? The measure of the angles on the inside or outside?
Inside.
On the interior add up to 180, right? Inside, interior adds up to 180. Anything else you know about triangles? Or what?
Nothing.
Okay.
Or
Scalene, isosceles, equilateral. What the heck does that mean, Bryce?
These are 3 different angles.
Okay.
2 sides equal, or all 3 sides.
Okay, so all 3 sides might be different. You might have 2 sides that are equal in length, or 3 sides equal in length. And it looks like that's something we're going to hit down here. So yeah, you guys have a pretty good idea of what some of the characteristics. And I think today that what we want to do is say, how do we take these characteristics that we know about triangles and apply them to some of the theorems we're going to look at today. So to get started, guys, 12.1 right at the very top is talking about angles of triangles. Specifically, what again, guys? Angles. We're going to look at some side stuff as well. And what we want to ask today is, how are the angle measures of a triangle related? There's going to be a lot of theorems that we talk about today that work with this. But in order to answer that question, we need to be able to, first of all, classify triangles by sides and by angles. We're going to talk about finding an interior and exterior angle measure of triangles. Interior meaning angles where? Inside. Exterior meaning angles where? Outside. Okay. One thing I'm going to tell you to recall today, if you have this still bookmarked or anything in there, you might want to get into your Chromebook this morning, and you might want to revisit that distance formula calculator. So if you have your Chromebooks this morning, I would say find that distance formula calculator and get into that again. If you can't, just do a Google search, distance formula calculator. You're going to need that for some of the things that we do today. All right? You're going to need that for some of the things we do today. Okay, guys, vocab, I'll try and squeeze this in here today. I obviously didn't make me much room yesterday. I was typing the notes during the ball game yesterday, and obviously forgot to do something with it. So that's okay. We'll make it work. Interior angles are going to be angles inside or outside of the triangle? Inside. Going to be angles inside, right? Angles inside of the triangle. Okay? How about exterior angles then, guys? Okay, angles outside. I'm going to show you what I mean by angles outside of a triangle. Blow this up a bit. I'll have you kind of sketch this in here the best that I can. Here's what I would like you to do. For triangles, draw a triangle right here. Blue, blue. I'm going to get a different color here. Hang on. Draw a triangle like this for me. Okay, do you see that triangle? Looks like one side got extended quite a bit of ways, right? When I start talking about exterior angles for a triangle, we're talking about take one side and continue to extend it so it forms an angle not on the inside, just on the inside of that vertex, but it also forms an angle on the outside. So this here would be considered your exterior angle right here. By the way, guys, if you have an interior angle right here and an exterior angle right there that I just kind of put a couple of dots up there by, what's going to be true about the sum of the angles for that interior angle adjacent to that exterior angle? It's going to add to 180. That's that straight line application, or linear pair. Remember we talked about linear pairs? Isn't an interior angle adjacent to an exterior angle going to form a linear pair again? And you know linear pairs add up to 180 degrees. Okay? And then, guys, the last thing, corollary to a theorem. I'm not going to worry about this too much. Corollary to a theorem is like, okay, listen to this. I have some quarters and a dollar bill. Totally, I have $3. I have some quarters and a dollar bill. Totally, I have $3. How many quarters are there? 8 quarters. How do you know that? You have to have $2 in quarters, right? And 8 quarters is $2. Corollary to a theorem is just like kind of adjusting some kind of a theorem or rule and coming up with another rule from it. So it's like saying this. Corollary to a theorem you're going to talk about is going to be dealing with right triangles, okay? It's going to deal with right triangles. It's going to deal with right triangles. In a right triangle, one angle must be what, guys? 90 degrees. So I'm going to blow this up a bit again. It says this. If you have a right triangle right here, guys, here's your right triangle right there. Okay? And you know this angle right down here is how many degrees? 90 degrees. Well, of the remaining two angles, this angle up here and this angle down here, of the remaining two angles, what do those two angles have to add up to if one angle is already 90 degrees? Okay, so the corollary to a theorem we're going to talk about is going to be, well, you know angles in a triangle add up to 180. But if you have a right triangle, that situation, if you have a right triangle, then they're saying minus that right angle, the other two acute angles that you have in there are going to add up to 90 degrees totally. That's all that's saying. But that's only in what type of a triangle? Right triangle, okay? Looks like I've got laundry to do, Court.
What?
Looks like a big laundry pile down there. Okay? All right, let's rock and roll here, guys. Core concepts, some of the stuff that we hit, and this is some of the stuff that you knew already. Okay? We're going to talk about classifying triangles by sides. What's the first name again here, Bryce? Scalene. Let's sketch this. Here's an example of scalene triangle. Boom. There it is. It's scalene because all sides are different. You might have something like 3, 5, and I don't know, 7 right here. Okay? 3 different lengths. That would be an example of scalene. Isosceles again. What's isosceles mean? So if this was 4 and I said maybe this is 6, what do I want this side over here to be then? Or either one, 4 or 6. 2 sides are equal, right? And then obviously when you get to equilateral, what's true about all sides? They're the same. So if this is 5, this is 5, this is 5. Don't forget, they use tick marks to identify They use tick marks to identify congruent lengths. So where would the tick marks go here on my isosceles triangle? Okay. Okay. That's classifying by sides. You can also classify triangles by what else, guys?
Angles.
Angles. What's acute mean?
Less than 90.
All angles are less than 90. How about a right triangle? 1 is 90. Obtuse.
One angle is more than 90.
And then how about equiangular?
All angles are 60.
If you have an equilateral triangle, you have an equiangular. Okay? Just the matter is how are you classifying it? By sides or by angles? And that should be stuff that's pretty elementary. You should know that. You should know that stuff, right?
Yes.
Okay. Well, let's maybe jump into the stuff that we're not 100% sure about then on page 2. Okay, on page 2. Let's take a look here. Let's get rolling here. Guys, it says classifying triangles by sides and angles. So here we go. I'm going to put some angles and some sides in here on example 1. You do the same. Okay. Classification by side, what is it? Classifying this by sides, what is this? Scalene. Scalene because all the sides are different. How about the classification by angles?
Right.
So right. So this triangle would be considered a right scalene triangle. I have a fish that is named right scalene because he looks like a right scalene triangle. He's an angelfish.
You actually have one?
Yeah, it's named right scalene. It's not a joke.
Pretty funny. You sure?
Yeah, I made that up. I have a fish named Ferocious. He's kind of mean.
You got a dog named Terry.
What fish do you mean?
I have
Try swimming with piranhas.
I have a dog named Milo.
He's a terrorist.
He's a West Highland terrorist. Holy cow, that guy is crazy.
You seen that episode of Rick and
All right.
Morty where he swims
This is where your
and bite him?
This is where your distance formula calculator is going to come in handy for you. Okay. Couple things are going to happen here. This example 2, mucho importante, if that's how you say it. I'll say it in English though. Very important. This is very important, okay? If you guys can handle the concept of what's going on right here and talk about how do we take the things that we know about triangles and start complying them with coordinate geometry and say, oh, that's a certain type of triangle because, or oh, that's a certain type of triangle because. Let me show you what's going on here, guys. I'll blow this up a bit. It says plot triangle ABC with the following vertices. So guys, help me out. Where is vertex A at?
0, 3.
So right here is A. Where's B? So right 7 up 1. And then help me with C. 1, -1 you say?
Yes.
Okay, so I'm going to do my best to draw this triangle in here. Give me a second. Oh, how do I feel today? You know what? I want a different color today. Let's mix it up. Let's get crazy today. How about hot pink? Okay, here we go. I'm going to do my best to draw this. Don't laugh at my art. That's pretty close, isn't it, guys? Okay, get your triangle plotted in there first of all. Okay, get your triangle plotted in there first. Now, what I want to do, what I want to be able to do is this. I want to be able to look at this triangle and say, well, we've plotted this. And it says, first of all, classify it by what, guys? Classify it by sides. And then determine if it's also a what? Okay, let's worry about this side thing first. How in the world are we going to go about finding sides in this? Any idea? Looking for sides. We're looking for a certain length, right? What do you think we're going to have to use to find the lengths here? Distance formula calculator. So let me do this here. Let me pose this to you here quickly. Let me pull this distance formula calculator. You guys are going to help me. Maybe. Come on. We are experiencing technical difficulties. All right, distance formula calculator. I don't know which one you guys use. It really doesn't make any difference. I'm going to use, is it okay if I use the first one? You guys okay with that? Okay, help me out with this, kiddos. Over here with this, we have, I wish I would go over there. That's okay. Let's find this distance from A to, what is this point down here again? Okay, isn't that C right there? Okay. So, you guys, let's find the distance from A to B first. So let's do that. So I'm going to go ahead and type in my first point. So my first point A, what was the coordinate of A again? 0, 3. And then how about my B? What was the coordinate of B? Was it 7, 1?
Yes, 7.
Okay, it looks like to me we get a distance of about how much there, guys? What do we get for distance there? 7 point, we'll round up to 7.3 right here, right? Sure. Sure. All right, 7.3. So I'm going to label that right here. You guys do the same thing as well. We're going to label a distance from A to B. How long here again, guys? 7.3, approximately 7.3 units. Okay. Who would be willing? Who's into a distance formula calculator for me right now? Kinsey, will you punch in B to C, which would be 7, 1, and 1, -1 for me for points? There You got that roof a lot up there. I don't know why. Maybe it's a ghost. I don't know.
Charlie.
Some people claim there is a ghost in this school, but I don't know.
There's a ghost in this.
I will say this. I will say this. It's very spooky to come in here on a day when you know you have to grade papers and there's nobody in the building and it's nighttime and all the lights are off. That's kind of spooky. Won't lie. Kinsey, have you got a distance from B to C? I'm sorry? It's not working. Well, let mine work here then. What are the values again, guys? Help me out. 7, 1, and what else were they?
Ouch!
7, 1, and what else?
1,
Negative 2?
-1.
1, -1. All right, looks like a distance that I'm getting here.
6.1.
You guys agree about 6.3? 6.3? So this distance is 6.3. What else do I need to find the distance up to classify this by side then? From where to where? A to C. So let's do that quickly. You guys tell me the points at A and C. C is already 1, -1, right? So what was my point A again? 0,
3.
I don't know why it goes by 2 tenths like that. I can't stand that. I don't know why it does that. 0, 3 it was, kids?
Yeah.
I'll calculate this. I got 4.1. 4.1. So watch this right here. You're going to have some kind of a distance formula calculator. You're going to use the distance formula calculator to punch in point to point to find the length of each segment. What do we come up with for classification of this triangle by sides? What kind is it? Scalene, isosceles, or equilateral? It is scalene. It has to be scalene because all 3 sides are what? All 3 sides are different lengths, yep. Now, the question becomes this. They want to know right here, determine if the triangle is what type of a triangle. Right triangle. Right triangle being one of the angles has to be how many degrees? 90 degrees. Now, if you recall right here, guys, if 2 lines form a 90-degree angle, they intersect in such a way that the lines are perpendicular. And we know things about perpendicular lines in a coordinate plane as they relate to their slopes. What is true about intersecting lines that are perpendicular to each other? So flipping. Ah, what is it again? Opposite reciprocal, the most devastating move in all of wrestling, called the opposite reciprocal. Okay? Yes, the opposite reciprocal. Now, if I had to ask this question, guys, just looking at the way this is drawn in a coordinate plane, just looking at the way this is drawn in a coordinate plane, which of the 3 vertices, A, B, or C, looks the closest to a right angle?
C.
Angle C looks like it might be a right angle down here, right? So what that means for me is the following. Let's look at the slope from A to C. Let's look at our slopes. From A to C. And our slope from what? B to C. Let's check this out. We can just count, rise over run. Yeah, it looks like to me maybe right down here, this side and this side, they might be a right angle. I don't know. Okay? Guys, from A to C, how far down do you count from A to get to C? Count down for me. 1, 2, 3. I count down 4. Do you guys agree?
Yeah.
And then I count right how much? 1. What's that make that slope? Rise over run. -4 over 1. All right. Let's check this one right here. from B to C. How far do you rise, guys? 1, 2. How far do you run?
6.
What's 2 over 6 going to reduce to?
1/3.
1/3. We're pretty gosh darn sure that A and B, just by visualizing, are not going to be right angles. We could check the slopes and verify this. I'm not going to, but my question is this. Is angle C a right angle? Yes or no? Is 1/3 an opposite reciprocal of -4/1?
It is not.
The negative turned to a positive. That's good, right? But did the 4/1 turn to 1/4 or something different? That's not good. So I'm going to say this. I'm going to say 1/3 from this right here. 1/3 is not an opposite reciprocal to what? Very good. It's not an opposite reciprocal. This is not an opposite reciprocal to -4/1. So is this a right triangle or not a right triangle? So this is not a right triangle. Okay, 1/3 is not an opposite reciprocal to -4/1. What if that slope from B to C had been 1/4? Then it would have been a right triangle. Okay? So anytime they ask you, is something a right triangle, you're looking to see if something forms a 90-degree angle. And 90-degree angles are created when intersecting lines intersect in such a way where their slopes are opposite reciprocals of each other. So don't lose that sight. Okay? So 2 things that you're really looking at here, guys. You're using the distance formula calculator to find sides. Are we comfortable with that, number 1? Yes or no? Okay? Number 2, if we're looking at finding slopes of each side of a triangle, are we comfortable with just counting rise over run? Can we handle that?
Yeah.
Okay. I would think we should be able to do all of that. All right. Questions on the second page at all? Feeling pretty good about this so far? Any questions at this point? Okay, excellent. Anybody need more time with this? Page 3. Okay. A couple of theorems I want to hit. Show you an example here. Triangle sum theorem. You already know this. It says the sum of the measure of the interior angles of a triangle is always how many degrees?
180.
No matter what your triangle is here, guys. Here is what it says. If I have angle X, angle Y, angle Z, X, Y, and Z will always, 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 on the inside of any triangle, add up to how many degrees?
180.
Okay, so X plus Y plus Z equals 180. You already know that. That's stuff we've known. Now what might be new for us is the exterior angle theorem. Okay, this is the one you want to make sure you get drawn correctly. It says the measure of an exterior angle of a triangle is equal to the sum of the measures of the 2 non-adjacent interior angles. Let me show you what's going on here. Here's a triangle with one side extended. Okay, I'm going to call my triangle X, Y, and Z. And I'm going to call this angle A over here on the exterior here. Okay? I'm going to give me some room here. And I'll show you what's really happening here. I'm going to draw the same triangle again over here on the right, with that bottom side being extended so we form an exterior angle. And I'm going to put some angle measures in here. You help me. 60, 40. What's this angle up top have to be right up here? Has to be 80, right? What's the angle on the exterior have to be? 140. They add up to 180 right down here. All right, here's what the exterior angle theorem says. It says any exterior angle to a triangle, that measure is equal to the sum of the 2 non-adjacent, meaning not touching. The 2 angles not touching the exterior angle, it's equal to that sum. So here's what they're saying. Here's your exterior angle right here of how many degrees, guys? 140. Which two angles does that not touch? What angle measures is 140 not adjacent to? 60 and 80. Oh, by the way, what does 60 and 80 add up to be? 140. So what this says is the following. Watch this. I'm just going to do this in the middle. In the middle right here. Oh, I screwed that up big time. First mistake I've made all week. I'm going to put some numbers in here. 100. This is 50. What does this have to be up top? Has to be 50 because the two angles inside the triangle that don't touch that exterior angle out there, they have to add up to the same thing. This has to be 50 then, right? By the way, what would this angle down here be then? 80. Take 50 and 50 and 80 and add them up. 180. All right? So here's what we're saying right here, guys. What would angle A equal in this situation? What plus what? Okay, so by this right here, you would say angle A is equal to angle X plus angle Y. That's all that's saying. Okay, so let me pull an example here. I'm going to pull an example here. I need to get this labeled up for you on example number 3, finding an angle measure. Oh, I like this stuff. I think it's fun. Does that make me weird? Wait, don't answer that.
Yeah.
Don't answer that. I already knew the answer to that question even before I prefaced it with anything. Okay, I need to label this triangle first, so you do the same thing. This is angle, or this point is P over here. This is Q. This is R. Down here at the very bottom is S. Okay? And we have to find the measure of angle PQS, how many degrees this is. And I'll show you how we're going to label my triangle. So make sure you've got those vertices in there. I'm going to call this up top 3x plus 25 right here. This angle is 3x plus 25 on the exterior. Angle S is going to be 65 degrees. And this is going to be up here, 2x. So the whole idea in this example 3 says find the measure of what angle? I'm looking for angle PQS. P to Q to S. I have an exterior angle, two non-adjacent angles. What's the 3x plus 25 have to equal the way it's set up? 2x plus 65. These two on the interior that are not adjacent to this exterior angle have to add up to equal this. So here's how we're going to solve this. We're going to say 3x plus 25 equals what on the right, guys? 2x plus 65. So back to elementary algebra here. Subtract 2x from both sides. And I have x plus 25 on the left equals what value? 65 degrees. Now, subtract 25, what's your x value? What's your x value? 40. Now, guys, if this has just said solve for x, would we be done? Well, yeah, you'd be at 40, but is x, once it's found, once it's solved for, is that the end all here? What do you have to do now? You have to substitute back in right here. So to find the measure of angle PQS right up here, we need to take 3 times what x value now, guys? 40. So the measure of angle PQS becomes the following. 3 times what? 40 plus 25 when I plug that in. Not very good at math. 3 times 40, please. 120 plus 25. Okay, so it's 145 degrees. By the way, what would this unknown angle be up here at R? Does 80 and 65 add up to that 145? So are there ways of checking to know you're correct after you substitute stuff back in? You bet there are. Okay. An exterior angle to a triangle is equal to the sum of the two non-adjacent interior angles. That there makes sense in terms of what we just did there? Okay. Well, last couple things right here are pretty simple then. This corollary to a theorem is a statement that can be proved easily here in example 4 using the theorem. It says the corollary below follows from the triangle sum theorem. Here's the deal. If I have a right triangle right here, guys, and I call this angle x down here and angle y, this corollary to a theorem that I'm talking about involves right triangles. Do you guys agree on this triangle right here, x plus y plus the 90-degree angle would equal what value? Okay, so what the corollary to this theorem really is, it says, hey, if you have a right triangle, then this x plus y would have to add up to what value then, guys? 90. Yeah, if you subtract 90 from both sides, don't you end up with x plus y equals 90? You guys agree with that? Okay. Well, here's the situation down here. I want to kind of apply that to this right down here. It says the measure of one acute angle of a right triangle is 1.5 times the measure of the other acute angle. What type of triangle again, guys? A right triangle. Okay. I know that right triangle, that's 90 degrees. So that means that whatever I have for an angle right here, and whatever I have for an angle right here, they must add up to 90. Okay? It says of the two acute angles that we're left to solve for, one is 1.5 times larger than the other. Okay? In this triangle, which angle looks larger? This first one I looked at, or second one that I circled? First one. So I'm going to call the smaller one angle x. So that means the bigger angle is 1.5 times bigger than 1x. So if the smaller angle is 1x, how do you think the expression is going to look for a bigger angle here? It is 1.5 times that. 1.5x. Okay? These two angles that are circled right here, you know they have to add up to how many degrees? 90. So couldn't I set an equation up as 1.5x plus, boy, it's hard to write on when they're walking on the ceiling up there. Lionel Richie sang a song, Dancing on the Ceiling. You remember that song, Mrs. Olson? Yeah. Oh, what a feeling I get when I'm teaching when they're dancing on the ceiling, eh? All right, never mind, not funny. What's 1.5x plus 1x? 2.5x. Help me with my math here, guys. 2.5x equals 90. Somebody do this for me. Take 90 and divide it by 2.5, please. Who's got that for me? 36. My x value is 36. Guys, do we have the number I need now to be able to solve for the unknown angle measures? What would this angle down here in the bottom right have to be? 36 degrees. What would this angle up here have to be? 1.5 times what? 36. 54 degrees. All right, well, I already know what 54 is 1.5 times 36 because that's what we did with the 36 to solve it. Quick question, do 54 and 36 add up to 90?
Yes.
Okay. Guys, there isn't anything in here that's a surprise. There isn't anything in here that we haven't covered that you won't see in the assignment. So my question to you is this. What questions have you got about this assignment in the first place? Any? Okay. Tell you, chapter 12, look, it's a fun chapter, but we're going to work pretty hard at it, okay? It starts out nice, but it does get pretty difficult as we progress. So again, notes important or not very important? Make sure you're paying attention on note taking, okay? Those people that made arrangements to either finish your test or make up the test, make sure you follow through. And I'm going to send out the big ideas assignment here, and we'll get going with this, okay? Any questions before I shut this down? Going once, twice.